Hi everyone. In this video, I'm going to be talking about classification of elements and periodicity in their properties. First, let's talk about why do we even need classification of elements? Well, let's imagine you have just one element named iron and you have to talk about or remember its properties, its atomic number, atomic mass and everything about it. Well, it does not seem to be very difficult. Let's imagine you have not one but two elements, let's say again hydrogen, whose properties and everything you need to remember. Again, not that difficult. Now let's imagine you have some more elements whose properties you need to remember. Well, this is a little difficult. Now imagine you have a total of 118 elements whose properties you have to remember correctly. Well, that seems a quite tough task. And that is why we need something called classification of elements. If we are somehow able to classify these elements in various groups, we just have to memorize the properties of the group and not the individual element, and that is why we need classification of elements, and that's why it's so important. So this classification was so important that scientists were clearly obsessed with finding some kind of a pattern and trying to classify the elements in various groups. There were various attempts made for this process. One of the first attempts were made by scientist Daubonnier, and he tried to classify a total of 9 elements in the form of 3 triads. As you can see, each triad has 3 elements. It was observed when the elements were arranged in order of increasing atomic masses in each triad, the atomic mass of the middle element was somewhere in between the atomic mass of the rest of the 2 elements. This was called the law of triads. Since the Daubonnier triad was only able to classify the total of 9 elements, that is why it was not very useful and hence it stand rejected. Then came another scientist whose name was Champetier, and he gave a very different kind of classification. He gave a 3D kind of representation of the then known elements and he made a periodic table out of it. Since no research paper was able to publish a cylindrical 3D table, that's why, well, this model also was rejected. Then came another scientist, John Alexander Newland, and he also arranged the elements in order of increasing atomic weights. He realized that the properties of every first element resemble the properties of every eighth element, just like the octaves in music. And that is why this law was called the law of octaves. Since this law was only applicable till element calcium, and that is why this law was also rejected. So before starting with the Mendeleev's periodic law, let's first understand whether we are on the same page as to what is periodicity. Periodicity is the tendency to repeat at regular intervals. For example, the motion of a pendulum is called a periodic motion of pendulum. The reason is that pendulum repeats its position after a fixed interval every time. The periodic law states that the properties of elements were periodic functions of their atomic weights. Let's see what this means. Scientist Mendeleev also arranged the elements in order of increasing atomic weights, and when he did that, he realized that elements having similar properties were kind of grouped together. In some cases, for example in case of tellurium and iodine, this criteria of increasing atomic weight was somehow ignored, because as you can see, the atomic weight of tellurium is higher than that of iodine, but the main reason is that iodine has similar properties to chlorine and fluorine, that's why they were grouped together. So the main criteria of grouping the elements together were that they should have similar properties and not exactly the atomic weights. One of the most striking features about the Mendeleev periodic table was that he was very sure that some elements have not yet been discovered when he made this periodic table. And that is why he left spaces for such elements in his periodic table, because he was sure that in future they will be discovered. Not only this, he was able to predict certain properties of these undiscovered elements to very high accuracy. For example, elements gallium and germanium were not discovered when he made this periodic table, and he named them Eka aluminium and Eka silicon, and he was able to predict properties like atomic weights, their densities, their melting points to very high accuracy. Because of this boldness of the Mendeleev periodic table, this table was highly famous at its time. But unfortunately, this one also was rejected, about which we will talk about in the next video. In this video, we talk about why classification of elements is even required, the Daubeney triads, the Newland's law of octaves, the Chan-Cotter's model, and the Mendeleev's periodic law. Now you all can head off to EduRev, practice the test, and read the notes. We'll meet in the next video. Thank you so much for watching.